Now let's talk about p-value method. So first step is to find p-value, which I will explain shortly in the next slide. You just need to follow the graph. Now you do have to know the decision rule. If p is lower than the significance level alpha, and the book uses this phrase, it says the null must go. That means we want to reject HO. If p is higher than alpha, then the null will fly. That means we don't reject HO. I'm not concerned about finding p-value because again, this will be found using statistical software. So just practice, experience a little in this section. This is how you should find the p-value. First of all, identify the type of test. If it's left tail test, and the p-value should be the area to the left of the test statistic. So you first find the test statistic and the p-value is to the left. If you have a right tail test, and identify the test statistic, once you find that, plot that into the graph, and the right tail area is the p-value. Now if you have two tail tests, if the test statistic is falling onto the left side, then find the area of the left tail and double it, you get the p-value. If the test statistic falls into the right side, and then you're going to find the right tail area and double it to get the p-value. So this is pretty much the whole flow chart to find the p-value. Now time to look at use this example, which is the X-sort method of gender selection. The claim is it increases the likelihood of having a baby girl. So suppose that the test statistic is now given. Actually, we could compute it. It's 3.21. So suppose it is now found, and let's find use two methods. One is the so-called traditional method. The other one is the p-value method. And the alpha is 0.05. I'm sorry, there's a typo here. 0.05, both for 0.05. Now, first of all, is this right tail test or left tail test or two tail test? From here, we do know this is right tail test. Once it is right tail test, using the traditional method, this is what I would use. Draw a bell-shaped curve. Use 0.05, which is the alpha. Find the critical value. And if you can recall that we found this in the last video, it is 1.645. Okay, 1.645 in the Z standard normal distribution. You just go to the StatsCrunch, type in the right tail area 0.05, and make sure the symbol is greater than, and this should return. Now after that, take a look at 3.21. Where's 3.21? This is 1.645. 3.21 is way out here, right? 3.21. So the 3.21, because it's located on the right side, which means the rejection region, therefore we reject HO because the test statistic 3.21 is in the rejection region. Rejection region, right? So that's how we use the traditional method to test this claim. Now, if you can recall that when we reject HO, that means we are in favor of H1. H1 means the method is effective. Therefore, we can now conclude that, well, this method is really increasing the chance of having baby girl. It is effective. So this is the traditional method. Now let's take a look at the p-value method. The p-value method, first of all, this is a right tail test. Therefore, I'm gonna draw a bell-shaped curve. Mark the test statistic, which is 3.21. So I'm gonna mark the test statistic 3.21. And what is my p-value? P-value is the area to the right of this test statistic. So this is the graph I'm referring to. So in order for us to find the p-value, we now need to use the StatsCrunch. Here, 3.21 is what we have as the value. It's not an area, so it has to be typed in this box. And it is a right tail test. That's why I choose the right side. And let's compute. So when we compute it, this is the p-value. So p-value is 0.0007. Now, after we found the p-value, and so we now see that p-value is equal to 0.0007, and it is certainly less than the alpha 0.05. Again, sorry, this is alpha is supposed to be 0.05. P is low, the null must go. Therefore, we conclude that we have to reject HO. We are in favor of H1. So this is the p-value method. They both should be consistent, reach to the same conclusion.